Okay, this is the part 2 video. We already did 1 to 15. Let's bang out 16 to 30. Okay, 16, they give us the initial velocity and final velocity in time, and they want to know how far does it go. Let's take a look. They give us VI, VF, and T, and they're looking for D. I think we saw a problem just like this not too long ago. In order to solve for displacement, using the formulas on the reference table, I would need to find acceleration first. Like I could do d is VIT plus 1/2 AT squared, or VF squared is VI squared plus 2AD, but I would need to solve for the acceleration first. And I think just like last time this happened, this is a classic two-step problem, where if you're trying to solve for something, and then you find out you actually need something else on top of it, you go off and solve for that thing as a second step, and bring it back. So in this case, I don't have the acceleration. Now I do have V initial and V final, so I could do delta V over T to solve for the acceleration. But actually, there's a version of the average speed formula that can solve this problem in one shot. It's not on the reference table, but it's handy to have anyway. Starting with V equals D over T, that's actually average V equals D over T. So average, you add up the initial and final values and divide by 2 to get the average. If I solve for D alone by cross multiplying, I get D is VI plus VF over 2 times T. Now that is a good formula for finding displacement with accelerated motion when you don't actually know the acceleration and doing it in one shot. So I plug in my numbers, my V initial, my V final, and my time, and I get 120 meters, and for some reason the answers are in scientific notation, so 120 is actually 1.2 times 10 to the 2 meters. Choice 3, next. So there's 17. We have a V initial of 13 meters per second, a V final at 25 meters per second in 5 seconds, and it wants the acceleration, delta V over T, V final minus V initial over the time, 2.4 meters per second squared, number 18. Alright, so number 18, it says we have a truck that in the same 5 seconds, so time is 5 seconds, it goes the same distance that the car went in number 17, and it says it's a constant speed, so I can use the constant speed equation of V equals D over T, and it wants to know what is that constant speed. Well, this is a two-part question because I don't know what D is. Yeah, it's the same as the car in 17, but I don't know how far the car went in number 17. Well, we can figure that out. So just refer back to the information of the car from 17. We have V initial is 13 meters per second, V final is 25 meters per second, and the time is 5 seconds. And now I also know the acceleration is 2.4 meters per second squared. So I could really do D is VIT plus 1/2 AT squared with the information from 17. And again, just to be clear, all of the information that I'm putting right there, I'm actually getting from over here. So that's back and forth. I'm using that info, so just to be clear about that. So yeah, like I said, two-part question. The first part was going and solving for D, which I did. I got the 95 meters, and then I took that 95 meters and I stuck it in for D on V equals D over T, and I get 19 meters per second for that average speed for 18. All right, 19. So 19, starting from rest, says uniformly from rest, so V initial is 0 to a speed of 15 meters per second. That's V final over 100 meters. What's the acceleration? So delta V over T won't work. I don't know T. So let's do VF squared is VI squared plus 2AD, because I know VF, I know VI, I know D, solve for A. So you get 225 is 200A, so A is 1.1 meters per second squared, and that is choice 2. All right, 20. 20 is a vanilla question. I got VI and VF, 2.5 and 9 meters per second respectively, over 3 seconds. What's the acceleration? Delta V over T. Final minus initial over the time, 2.2 meters per second squared. Choice 2, next. Now, 21 looks a lot like 20, except instead of giving the time, they gave the distance. So you can't do delta V over T. I have VI, VF, and D, and I need A. That's VF squared is VI squared plus 2AD. Now don't forget to square. If you see squares in these equations, do not forget to square. Alright, let's solve for A. Sometimes I'll write in these little intermediate math steps, and sometimes I don't. But 7 squared is 49, 2 squared is 4, 2 times 12 is 24, so you got 49 equals 4 plus 24a. Subtract 4 from both sides, divide 24 from both sides, and you get 1.9 meter per second squared, and that is choice 1. Again, the rounding for sig figs is based on the original significant figures in my numbers. I have 2.0, 7.0, and 12. That's 2 sig figs. Alright, let's keep going. So we have T, VI, and VF, and we want A. So this should be an A equals delta V over T, but they want the magnitude and the direction. So let's see what we get. In the comments about the directions, they specified east in the problem for both of the velocities, and they're asking for the direction of the acceleration in the end. Well, I'm going to put both velocities in as positive because they're both east. If one was east and the other one was west, I'd have to make one of them negative. Also notice that it's slowing down, so if I have a positive velocity and I'm slowing down, acceleration acts against the velocity, the acceleration is going to be negative. Watch this. 15 minus 25 is negative 10. Negative 10 divided by 5 is negative 2 meters per second squared. Now, it says give the direction. I would accept negative as a direction, because positive and negative are directions, but it does say east. So if you're calling east the positive direction for the velocity, and the acceleration comes out as negative, that would be 2.0 meters per second squared west, acting against the velocity to slow it down. I would take either answer. I may have said meters per second. That's negative 2.0 meters per second squared, or 2.0 meters per second squared west. All right, 23. Okay, comments on 23. It said that the velocity is east, and then the acceleration is also east. So if I'm calling that 5 meters per second a positive velocity and the acceleration is in the same direction as the velocity, I'm going to put the acceleration in as positive as well. Also, comments on units. Notice that there's a square in the acceleration units. It's meters per second squared or meters per second per second. Just be careful. Don't actually square the two. The meters per second squared, the squared is just part of the units. But do square the time. That's 1/2 AT squared. Only the time is squared. And I get that question sometimes. People look at that equation and they're like, what are you squaring? Only the time. If it was squaring anything more than the time, they'd have to put in parentheses. It comes out to 150 meters. That is choice 4. All right, 24. All right, so we have a V initial of 15 meters per second. That's a terrible looking V. Let me fix that. V initial of 15 meters per second. A is negative 3 meters per second squared over 4 seconds, and they want V final. So if you're calling V initial positive and acceleration is negative, the acceleration is acting against the velocity, so that bike must be slowing down. So let's see what happens. Let's use the VF equals VI plus AT, which is just another way of saying A equals delta V over T, but I'm looking for VF, and this equation will get me there sooner. So let's see what we get. So the kid on the bike slows down from 15 meters per second to 3 meters per second. Choice 3. 25. Okay, they said we got a car going west, and it decreases speed from 30 to 23 meters per second. It doesn't say that it turns around, it just slows down. It does that in 2 seconds, and it wants the acceleration. And we wind up with a negative answer. So it said that the original velocities were west, and if I'm calling that positive, which why not? But basically, like if I called them negative, then I would have wound up with a positive acceleration. Point is, when you slow down, velocity and acceleration opposite direction. So keeping that in mind, you could say negative 3.5 meters per second squared, or you can say 3.5 meters per second squared east, because it's opposing the velocity. So that would be choice 1. Let's go number 26. So we have a runner? A runner. 12 meters in 4 seconds starting from rest. So that's V initial is 0, and they want the acceleration. So I would do D is VIT plus 1/2 AT squared and solve for A. 1.5 meters per second squared, choice 2. Let's go. So here we're starting from rest, so v initial is 0. The acceleration is 4 meters per second squared, and it's gone 8 meters. And wants to know what's the speed after that. We do vf squared is vi squared plus 2ad. Now you wind up with 64, but 64 is vf squared. Square root both sides. The final velocity is 8 meters per second, and that's going to be choice 1. Next. Alright, so we do VIT plus 1FAT squared for 28. Just to have a starting speed of 22 meters per second, an acceleration of 2.4 meters per second squared, 3.2 seconds, and wants to know how far it goes. So work it all out to get 70.4 plus 12.288, 83 meters. Just don't forget to square. That's 1FAT squared. So that's 1/2 times 2.4 meters per second squared times 3.2 times 3.2. Most common careless mistake is forgetting to square. Almost done. Alright, so 29. We have a constant speed. So that means the acceleration is 0. You can do like a d is VIT plus 1/2 AT squared and put in 0 for a, so the 1/2 AT squared piece just falls off. Or you can use v equals d over t. Here, you know what? Let me show you both ways. So v equals d over t, v is 20 meters per second, you're solving for d, t is 2 minutes, or you could do VIT plus 1FAT squared, where vi is 20, t is 2, and then you're going to solve for, and then the 1/2 AT squared goes away, you could just drop it off, goodbye. And then we go and solve for the distance, and then, what? 2 minutes? Oh man, put that in seconds. Nice try. They tried to trip me up. Nope, time is in seconds because the speed is in meters per second, not meters per minute. Alright, let's do that again. When erasing, you have to have sound effects. Alright, 120 seconds. 120 seconds. So over here we get 20 times 120, and that would give us 2,400 meters. Over here, same thing, 2,400 meters. Hey, it doesn't matter what equation you use. That is right. Alright, they tried to catch me slipping, and I was not. That is choice 4, 2,400 meters. See how they tried to do that on the second to last question? Sneaky, sneaky. Speaking of last question, 30. Man, they're going to put 30 on its own page. They could have had a harder problem or something. Delta V over T. No big deal. Pretty straightforward. Yeah, they gave us the directions, but we didn't really need them. We wind up with 2.5 meters per second squared. I think we saw this problem already. Anyway, 30 is choice 1, and that's all she wrote.